Okay, so we'll be talking about GNSS, Global Navigation Satellite Satellite System. So, what is Global Navigation System? Global Navigation Satellite System is the way we travel the source of direction for travelers, right? So in when we talk about the source of direction for travelers, it helps people know where they're going. Let's suppose if they want to go from here to here, so if the path they take, it is not using satellites, okay, but how it works is a very interesting concept. So we know that satellite what they use for the signals, they use radio waves, or yeah, radio waves. They use radio waves. And what's the speed of radio wave? As same as speed of light, 3 times 10 to the power 8 meter per second. Okay, so then when we talk about how it works, let's suppose if this is a person over here, okay, and there's a GPS in his device, in his car. So in space there's a antenna, or there's a satellite, not antenna, satellite, and that satellite sends signal to this car, okay. So, and this signal is sent at a time 0 0 and 0 0, okay. Then when this car, the GPS in this car, receiving time 0 0 dot 0 0, anytime, any value, depending on just whatever, okay. So the time sent, the signal sent at a time by the satellite till till the receiver of the GPS of the car receiving that signal. So if we subtract them, satellite time minus receiver time equal time interval, okay. So now we have time. We already know that the waves, what are which speed they're traveling at? Speed of light. So if we use the formula c, because c is the speed of light, c is speed of light, okay. C times change in t, delta, equal, what's this formula? This formula gives us distance. Let me write it in words. Speed of light times time interval equal distance between lie sorry between satellite and car GPS. Okay, then well now we know the distance. This is a distance, same is that the time or the speed. We know the time. Well, we know all these things, but then we don't know the angle. Okay, we don't know the angle. So how can we know the angle? Just do the same thing, but times many satellites. Instead of one satellite, there are many satellites around it. Okay, they all are doing the same thing with this single car. They all are being connected to the single car. The time is being measured, the distance being measured, everything happening. Okay, then wherever the signal, they're common. Suppose at this point they're common. This common spot as we got connection with not between, with different satellites. Okay, then this is the position of car. Okay, so here is the most common, but then even if we know how to do this, let's suppose we go inside. Okay, let's name the next topic as error signal loss, because we can lose signal. So what could be done? Well, this is most the experiment, or the what we can do if we have signal loss is we use dead reckoning. Okay, this is what old time sailors used to do, done by sailors in old times. Okay, so how it used to work is, let's suppose your ocean's not orange, it's different color. So let's suppose there's a sail and it's going in a certain direction. So when they lose, because they have compass and the compass only gives direction, so when they lose, or when they want to figure out at what time where they are on the map, this is a map, and they want to know which position they are on. Okay, want to know where they are, where they are. Okay, so what they do is where they are is where they are. Okay, so what they do is that simply they are always keeping the time, they're always keeping their time that when this left that area, and when they have that's the time, plus they measure the speed. How they measure speed is different. Like they throw a rope down to the ocean, and there's a knot attached to the road, and with each knot going out of that ship with each interval, that tells the speed of that ship. Not connected, not connected, connected to the rope in thrown in space, thrown not space, water, thrown in water tells the distance. No, not distance, time, speed. Okay. Now we have the speed, we have the time. So what's the relationship? Distance. How we can find distance? Distance is d is equal time times speed times speed. Sorry, d is not the proper way, it's s. Okay, but here some things are kept some things are kept like negligible. That wind speed, wind speed, wind speed, then uh, weather is clear, weather is clear. These are things or things ignored, ignored. Okay, so yeah, this happens. When does it happen? When this can happen nowadays as well. How? The car or the train or whichever uses navigation gets inside the tunnel, signal is lost, signal is lost. So this can be used nowadays as well, can be used. If for those who think, for those who know physics and are interested in physics, they would keep this in mind. Thank you.